Hey everybody, let's go and add some monomials and polynomials. Are you with me? Here we go.
Okay, so everybody, we are going to be looking at adding and subtracting polynomials today. And this is going to continue your algebra journey as we move from looking at linear equations to quadratic equations. And a lot of review probably for today and a lot of vocabulary. So hopefully you guys have a notebook of some sort and you are ready to go. You have some different colors because we always love colors. And yeah, off we go. So the first thing that I would think about if I was a kid is what are these things called polynomials? Because it sounds kind of crazy. I was like, what is that? Well, um, let's just break it down first. So the very first thing we need to know is that there is actually something called monomials, and monomials, the root word of that is going to be mono, which basically means one. Okay, so we're kind of thinking of that, and it's basically a number or a variable or the product of those two things with whole number exponents. So that's basically what it is. So let's just kind of figure that out. So it's a number or variable or product of those two, which is important. So product, not addition. That basically has whole number exponents. So it doesn't have negative exponents or fractional exponents. Now, the biggest thing for me when I was a student is seeing different examples of this. So let's give you some examples of what that kind of looks like. And let's see, what kind of color should we get here? Let's get a nice green. So here we go. And a couple things just kind of note a little bit. So here's the monomial. And we want to know also what the degree is. Okay, so we're going to kind of do this. So the degree is always the part that math teachers are always going to ask you. It's the sum of the exponents of the variable. So not the constants, but of the variable. And I'll give you some examples of that. Sound good? Okay, cool. So here we go. Let's get a nice little purple. I think so. Nice purple or violet, I guess you could call it. So monomial, so 10. So this is a number, right? This is a number. Is this the degree? So what would the degree be of this one? It's the sum of the exponents. Are there any exponents? Nope. So the degree is 0. Okay. Let's say you had something called 3x. So say you had a term called 3x. That is a monomial because this is a number, 3 times a variable. So this is the product, right? That's the product. And what is the sum of the degrees of the variable? So remember, there's an invisible 1 right there. So we're going to say that's 1. Cool. Now let's get something else. Let's have a fraction and say this is, I don't know, x, y squared. Ooh, cool. Again, there's an invisible 1 here, and we're only going to add up for the degrees, the variable. So you would say 1 plus 2, and we would say that would be 3. So the degree is 3. And you can also have like decimals. So you can have negative things. So say you had negative 0.5 and you had, I don't know, d to the 7th. You would say that is a monomial, because that's multiplying there. And we would also say that the degree there would be 7. So what are not? So what are not monomials? So let's just go and show that. So here we go. Whoa, let's go back here. Ooh, let's go to yellow. So what are things that are not monomials? So how are we going to go and trick you on tests? So this kind of goes back to that part of it has to be a product. It can't be an addition. So let's give you some examples. I'll give you some orangey kind of examples. Let's say you had something like 7 plus x. No, because it's an addition. Okay, it has to be multiplication. Let's say you had, I don't know, 6 over x. Nope. You can't have variables in the denominator for a monomial. So that's one. And a couple of reasons why. So this one's always like, this is like a rule that like, okay, I'll memorize that. Well, it comes down to because 6 over x is really 6 to the x to the negative 1, right? And you can't have a negative exponent for a monomials. So there you go. Let's say you had 7 to the power of x. Nope. Nope. Also, because you can't have variables in the exponent. Okay, cool. And the last one, which kind of builds on this one right here. Let's say you had, I don't know, let's say z to the negative 7. Also no. So your exponents cannot be negative when you're talking about monomials. So there's some non-examples that you need to know for that. So let's go and switch over to looking at the actual title of our lesson today, which is polynomials. So polynomials, whenever I hear poly, I always think like Polly want a cracker and pirates. Okay, but a polynomial is basically a monomial or a sum of them. So it's just taking two of those things, or even just like a monomial is a polynomial, and adding or subtracting them together, okay? Basically, if it has two terms, remember terms are separated by plus and minus signs. So if it has two terms, we call it a binomial, bi meaning two. And if it has three terms, you guessed it, we call it a trinomial. Tri meaning three. Always think of like tricycles, 3 wheels. And there you go. Okay. Now, a couple things you need to know. You need to know about the degrees. So again, these are the vocabulary things. We have degrees of polynomials. So for degrees, it's basically the sum, I guess the sum or the highest degree, the sum or the highest degree. Oh, that's bad. No, we're gonna edit this. We're gonna edit this. Can I go backwards? That's right. So let's talk about the degree of a polynomial. So the degree is basically the greatest, so the highest, so the greatest, the highest, biggest, however you want to say it, degree of the term. So you're looking at individual terms here. This always makes more sense when you start seeing some examples. Yeah, and then basically you also have something called leading coefficients. And the leading coefficient comes from the highest degree term. So you will have a leading coefficient. Remember coefficients, I always describe them as that thing stuck to a variable, right? So if you had like 5x, it would be the 5. That would be the coefficient. So you have leading coefficients. So let's just take a look at an example. Let's go and get, oh, I don't know, oh, pink. Sure, we got a nice pink. Let's say you had this, you had 7x to the, oh, I don't know, third? Sure. Plus 2x squared plus 18x minus 9. Ooh, that's a good one. That is a good one. So what kind of things do we have here? Well, we would say the degree, so I've made this in decreasing order, which is how you should be writing your polynomials. So the degree is this one here, so that would be 3. Okay, the 7 would be your leading coefficient. I'm going to write down LC. And of course, you see you have 4 terms. You have 4 terms here. Terms are separated by plus and minus signs. And don't forget this one, we call this the constant term because it's always going to be that. So that's your constant term. And you can see how it's decreasing exponential value. So 3, 2, and there's a 1 there. Okay, and that's how you should be writing it. And what do we call that? Of course, we call that standard form. So that's a little bit about monomials and polynomials and just kind of talking about basically or figuring out how we're going to talk about stuff. So let's give some examples. Like say I wanted to rewrite properly. So if I said rewrite, and I wanted to rewrite like this. Say you had something called 8x plus, I don't know, 9x squared plus 4. And I said rewrite it properly. So if you want to rewrite it properly, you'd have to put this term in front to be a decreasing exponential value. So you'd rewrite it as 9x squared plus 8x plus 4. Okay, so you're going to be doing that a little bit. So just making sure that you want to rewrite it, and that's what it is. A couple things to note is that this sign travels. So these signs travel, right? So there's also a plus sign here. So the sign goes with the term. So if you see my other math videos, I always ask you to always circle terms with the sign to the left. The only way that I ever see that kids kind of go wrong would be forgetting about that. So kind of realize that. So you want to see another example where if I'm going to see one where a kid's going to get mixed up, it would be something like this. If I did something like, what could I do? I could do this. 5 take away 6x squared take away 9x. If I was going to go and rewrite that, I would look at which one has a higher exponent there. So I would say this is negative 6x squared minus 9x, and then plus 5. So let's put it all together now, shall we? So we are going to go and start looking at basically how to add and subtract polynomials. So how do we do it? So we figured out what they are, I'm hoping. So these are the things to keep in mind. Number 1 is you want to line up vertically the terms with basically the same variables and exponents. We're going to fit all this in here. Variables, and I'll cheat a little bit, and exponents. So you want to have like x squares over x squares, and you want to have y's over y's. Whew, there we go. And then you just want to add and subtract. The only thing that I ever notice kids going wrong is to be very careful. So I'll put a little star here and I'll get a different color. Be careful of double negatives. Oops. So be very careful of the double negatives. That's all. So I'm going to give you a couple of examples and then we'll all be done. Boom. How does that sound? Everybody just said yes. Okay, cool. Example. Boom, here we go. Let's have 4d squared. We'll start off nice and easy. Plus 7. And we'll go and we'll add this to 3d squared plus 9. Okay, so Yeah, here we go. What is this? Just kind of just go through this one. So I want to work vertically. So I want to line up my terms according to what is going on. So I'm going to line up my d squares. So I have those d squares and these d squares. And I've made this question like super like straightforward because the only terms are all like terms. We're going to add here. So it's 4 plus 3. I always like to go like this. So I always like, if you kind of look at my cursor, I just naturally, I go 4 plus 3. I do that because it reminds me what's happening. Because when you're subtracting, it becomes a little bit more tricky. So that's why I literally use my finger when I do it. So 4 plus 3 like that. Cool. So that gets me 7d squares. Remember, the variable and the exponent stays the same. So these are 7d squares. And then 7 plus 9 is just plus 16. And you're done. Okay, so that's it. Where else is a common kid mistakes? So KKMs. For this one, some kids like might think that that's not 7d squares. They'll say it's like 7d to the fourth. I've seen kids do that because they think they add these. No, you don't. Those are d squares. So like this, literally, it looks like this. There is 4 of these. That's actually what it looks like. Okay, kind of crazy, I know, right? That's what it looks like. And then there's like, I just want to go and draw on my screen right now. That's all I'm doing. And there's 3 more. So like how many are there altogether? Come on, there you go. There are 7 of those d squares, right? So just don't do that common kid mistake. From there, okay? Let's get into just a couple more examples, like 2 more examples probably is all we're gonna do. I think I can already hear you like, I get it. Okay, you get it, good job. Let's go and do this. Minus 7. Sure, why not? X to the third plus 4x minus 1. Sure. Take away. 9x to the third plus 7. Okay, so here's an example of why I would want to work vertically. So I'm going to line all this up. So, and I can see some students maybe trying to do this in their head. Yeah, you could do that, I guess. So here's this negative thing here, right? So this negative thing, this always kind of causes some issues here. So let's talk about that. You are going to be subtracting. However, you might want to distribute this negative 1 against this and then add. I'm not going to do that, but I've seen kids do that. So if I just wrote what's in this bracket here, so I'm going to write down 9x to the third. Notice there is no x term, so I'm going to go like this. I'm literally going to skip over it and go like this. And now, just to make a very big point, I'm going to make this blue. Actually, I'll make it green. Is that we're subtracting now. Okay, because this subtracting sign is subtracting. Okay, so that realize that's what I'm doing. So now I'm going to go minus 7 minus 9. See my cursor? Minus 7 minus 9. Ooh, that's kind of tricky. That's going to be, and use a calculator if you have to, it's minus 16 x to the third. Now this is 4x minus nothing, so it's still 4x. This is negative 1 minus positive 7. That's going to be negative 8. So there's definitely some tricky stuff here that can go on. So really be careful with that. Some people, there are people out there, there are students that like to go and distribute this negative 1 against everything. They like to do that. And this is what they write. So I'll just show you the 2 different versions. Why not? All right, nothing wrong with that. So if I distribute that negative, so some kids like to do this. I'm distributing that negative. And now they aren't subtracting anymore because I've already gone in and basically distributed that. Now I'm going to get my blue. Now I'm going to add. Okay, this is the exact same thing going on. It depends on how you want to look at it. In my experience, this one causes less issues. Especially if you do the little like finger, cursor, pencil going around, you usually don't make any mistakes. Okay, like this one, like that. You usually don't make any kind of mistakes. So take it for what it's worth. And there you go. And do you want to do you want to know more? You know what? I think that's pretty straightforward. I think you got it. You're going to have lots of practice. Undoubtedly, your math teacher is going to give you lots of questions to practice because this is like a fundamental skill before we get into the work of quadratics. Have a great day, everyone.
Thanks everybody for tuning in to another edition of Math with Mr. Douglas, the Math Jedi. Until next time, have a great day.